Hi everybody, and welcome to Session 9 of the Systems Admin track of the Australia and New Zealand Summit 2022. I'm Mike Stone and I'm a Microsoft Platform Specialist in the Microsoft Migrations team of AWS Australia. Today I'll be talking to you about Microsoft migrations, where to start, how to leverage AWS and partners to provide the clarity customers need to start their journey to the cloud. In this session we'll be covering the following topics. Firstly, a typical customer migration journey. Secondly, how an optimization and licensing assessment helps customers along that journey. Thirdly, how AWS helps customers navigate all the considerations that come into play when considering a migration. And fourthly, a discussion on what we call modernization and what modernization means to us and why it should be part of any migration project. Now, to help the presentation along, I'll be using a fictitious customer that reflects a very common scenario that we see today. In this case, we have penny farthing cycles, selling cycling-related goods online for many years, but who are facing 3 events that require significant capital expenditure. As the CIO, I'm using this as an opportunity to investigate changing the way I deliver services today. So it's very tempting to do some initial modelling to estimate the costs of running in AWS, but this can be a big mistake. It's common for customers to get sticker shock at the estimated cost of the initiative, and it comes to a grinding halt at that point. I'll explain why this is the case and why engaging with AWS or a partner is a much better first step. Now, most migrations follow a very similar path. The first phase is almost always an assessment of what your environment looks like today, which leads on to some kind of business case that evaluates the opportunity to migrate and to modernize. I'll be spending the first part of this session discussing how to start the journey to a traditional migration, which we often refer to as lift and shift. And by that, I mean the customer is taking on-premise workloads, both physical and virtual, and looking to move them to AWS with as little change as possible. After the migration is complete, the customer will then look at how they can transform to make use of cloud services to improve agility whilst reducing cost. And I'll then be spending the second part of this presentation looking at another migration strategy, which we call modernization. Now, this is taking the opportunity to reconsider the current environment and identifying candidates for some kind of transformation as part of that migration. I should stress that these 2 options are not mutually exclusive, and it's highly likely that any migration would be a combination of both lift and shift and modernization. So as I just mentioned, the recommended approach is to start with the migration assessment, which will provide insights to the scale of the task and the likely operating costs once migrated. For customers starting on their journey with AWS, either directly or through qualified partners, we offer a free assessment engagement called an Optimisation and Licensing Assessment, or an OLA. Over the last few years, we've run over 1,000 OLAs, and this has highlighted its value over diving into one of the publicly available cost calculators, inputting configuration details of the current environment and getting a costing result that does not reflect the real operational costs of a migrated environment. Globally, the OLA engagements have shown that on average, cost savings of around 36% over the cost of moving a customer environment as it was on premise. I've seen results considerably higher than that myself. So what is an OLA? And how does it work? Well, based on the customer environment, we select the most appropriate of a number of different tools that are available to us to discover the size of the customer environment and collect over time performance statistics that will identify how efficiently that workload is running. We don't collect any personally identifiable information, financial information, or customer data, purely performance statistics that show how well the workloads are running today. This gives us vital insights that we can use to right-size these workloads in AWS. And in a later slide, you'll see why this is important. A typical OLA runs for between 2 and 4 weeks. And once the data is collected, we can provide valuable insights into how that environment runs today. It's very common for us to identify workloads that saw no activity whatsoever during the period that we were collecting the data. And this could mean that that workload is no longer required and should be retired rather than migrated. We also identify workloads that are over-provisioned, and this is equally common for on-premises environments where customers have to size servers and cater for the peak performance, which may only happen for a short time in any given year. In AWS, we can reduce the size of that workload to cater for general activity levels and to allow it to automatically scale up and scale back down again as demand requires. Our experience shows that less than 20% of on-premise workloads today are optimally sized. Similarly, customers commonly over-provision storage and have a buffer for growth. And again, AWS can grow as required rather than months in advance. As well as workloads that are over-provisioned, it's common for customers to have workloads that are performance constrained in some way. We identify those workloads and the cause for the constraint, typically CPU, RAM, network, etc. And we take that into account when right-sizing that workload in AWS. Another factor we take into account is software licensing. There are a number of different ways to license Microsoft workloads in AWS, and we walk through the options, identifying areas where we can save costs by reusing software licenses that the customer already owns. Next, I'll demonstrate why licensing optimization is a key part of that overall assessment. So as I said, one area we always focus on is licensing optimization, and this is why. Here is an example of the cost elements of a SQL Server enterprise workload. It happens to be running on a C5 extra large EC2 instance in the Sydney region using the AWS license included options, where AWS is providing both Windows Server and SQL Server licensing to the customer. Now, the overall cost of licensing and compute for this workload is just under $1,400 per month, but of that, the compute element is only $162 per month. The remaining nearly $1,300 per month is taken up by software licensing, and by far the largest proportion of that is SQL Server Enterprise licensing, which makes up 78% of the overall cost of that workload. Customers with volume licensing agreements with Microsoft, such as an enterprise agreement, can typically purchase their Microsoft licenses at a reduced cost and are often multi-year commitments. If we can utilize these licenses and reduce the cost of AWS instances and show ongoing value for those committed investments, we will look to do that. We also look to get value out of older licenses that the customer has perpetual rights to, but is no longer paying Microsoft for ongoing upgrade rights called software assurance. So all of this is called BYOL, or bring your own license. Many customers do not realize that they can bring some of their existing licensing that they've been using for on-premise workloads to AWS, but there are significant savings to be made where this is possible. Another cost element that this example highlights is the relative cost of SQL Server Enterprise versus SQL Server Standard. SQL Server Enterprise typically costs around 3 to 4 times the cost of SQL Server Standard. And it's very common that customers chose to license a workload with SQL Server Enterprise because there was a feature that was only available in the Enterprise Edition at the time it was being deployed. It's equally common that customers duly upgrade this environment with newer versions of SQL Enterprise as they become available, but because we're all really busy keeping the lights on, we don't have the opportunity to review whether the Enterprise version is still required. Over time, many of the enterprise features filter into the standard edition, so one of the things we can do is examine the features being used of a SQL workload to see if there's an opportunity to move from SQL Server Enterprise to SQL Server Standard as part of a migration to save costs. So this slide shows a summary of some of the OLA findings for penny farthing cycles using one of the OLA tools called Migration Evaluator. It shows 253 Windows servers across the estate, all on premises today. This tool can also discover servers that are in cloud environments if they exist. Now, we didn't discover any Linux servers, but the tools we use can discover and assess non-Microsoft workloads as well. That's one of the criteria we take into account when selecting the best tool for the environment that we're trying to monitor. Now, of these 253 servers discovered, only a small proportion were actively in use during the period that they were monitored, about 14.5%. Interestingly, and perhaps not an unusual example, to demonstrate the point is that 52.3% of the servers monitored saw no activity whatsoever during the period that they were being monitored. We term these zombie servers, and they are candidates for retirement rather than migration, and further inspection would be required to determine this. Now, this is another portion of the OLA findings, which highlights cost savings identified by the assessment. So up there, top left, is an estimated on-premise cost for this environment, which is at $807,000 per year. We use industry standard benchmarks to calculate this, but we recognise that every customer is unique. If this environment was lifted and shifted as is to AWS, the cost would actually increase to $950,000 per year. And this is the effect of not optimising compute instances and corresponding licensing. We see that many customers look to estimate the cost of their existing environments themselves using one of those free cost calculators that I mentioned earlier. And what they get by doing that is this as-is cost, and it's often a surprise to customers to see that their projected costs go up, and many potential migration projects stall at this point. Down there on the bottom right is the result of applying all of that additional information that we've collated during the monitoring process and right-sizing those compute instances and identifying opportunities to bring your own licenses with you. And you can see that that cost is reduced from $950,000 to $650,000. And that's really the value of the optimization and licensing assessment in a nutshell for customers. Now, there are lots of variables to consider when considering a migration, and we don't expect customers embarking on this journey to understand or cover them on their own. The options on this slide are a far from exhaustive list. Now, the good news is that we consider those for our customers and we walk them through the options to determine the optimal combination of them. Now, hopefully I've given you some insights as to why an OLA is an important first step in understanding a potential migration to AWS. And I'll stress again that this is a free engagement for customers and without any obligation beyond helping us set up the environment that we need to collect that performance information and giving us an hour of your time afterwards to present back our findings, as well as receiving a more in-depth report. Whilst I've been discussing a traditional lift and shift migration, that OLA data is also invaluable for the next part of the presentation, which is identifying suitable candidates for modernisation as part of a migration project. So, as I've just walked you through, a typical migration can be summarised as moving a physical or virtual machine from an on-premise server to a server in the cloud, the classic lift and shift approach. Architecturally, migration still involves operating virtual machines and licensing proprietary operating systems and databases to run them. And I'll now discuss modernisation. Modernisation offers the next step in the evolutionary journey, which is moving away from a virtual machine-centric world and move to more cloud-native operating models. This move can drive significant benefits, firstly by allowing organisations to become more agile in terms of how they can update and extend core business systems, which in turn greatly facilitates organisations' ability to innovate and to execute new initiatives. Secondly, organisations are able to reduce their reliance and hence spend on expensive proprietary operating systems and databases, as well as the costly and repetitive support obligations that are inherent with the use of these products. Working as I do in the Microsoft team at AWS, this latter point is a key part of any discussion we have with any customer. As I showed earlier, the cost of Microsoft software is significant. It's generally one of the largest line items in a migration-focused business case that we create for customers. Left unmanaged, software and associated support costs have a nasty habit of increasing over time rather than decreasing. Now, modernisation offers organisations the opportunity to end that dependency on expensive proprietary software and to break the cycle of constant upgrades and end-of-life challenges that have historically proven such a challenge. In the next slide, I'll talk a bit about what I mean by modernisation and what are the challenges and the constraints. So when I say modernisation, I'm referring to an en masse, a number of different approaches that customers may choose to take. Different applications may require different approaches, but broadly speaking, most modernisation journeys will encompass one or more of the following activities. Deconstructing large monolithic applications to smaller bite-sized chunks so they can be modernised component by component. Moving applications off Windows Server to either a Linux or serverless compute environment such as AWS Lambda. Containerising the application so that it can benefit from modern deployment practices. or changing the database that underpins the application away from a proprietary database engine, such as SQL Server or Oracle, to a lower cost open source database engine. Customers often also move to a managed database service as part of this transition to free up expensive and valuable DBA resources. Undertaking modernisation can drive huge benefits for customers. As an example, AWS customer Dow Jones recently undertook a project to move its business-critical real-time market data platform, used by millions of people on a daily basis, from Microsoft SQL Server to Amazon Aurora MySQL. As a result of making this move, Dow Jones costs were reduced by more than half when considering hardware, licensing, maintenance, rack space, and power costs. So modernisation makes a lot of economic sense. The challenge is working out whether an application is suitable for modernisation, what the appropriate modernisation path is for that application, the complexity of modernisation for the application, and also its dependencies. It should be noted that not all applications are suitable candidates for modernisation. Many customers run large portfolios of commercial off-the-shelf software products called COTS. Where this is the case, any decision around modernisation will be heavily influenced by the software vendor support considerations and whether or not the software vendor allows any access to the application code. By contrast, if the application is a custom-built application, built by an in-house development team, all modernisations are generally available to them. This means that across a portfolio of applications, it's likely that a number will be candidates for migration only, whereas others are potential candidates for both migration or modernisation. Historically, the only real answer to assessing an application's modernisation suitability, strategy and complexity has been to assign a consultant or a technical specialist to each application and then assess them one by one. This can be both time-consuming and expensive. In the last few years working with the Microsoft ecosystem, my team has been involved with numerous scenarios where customers have been looking to compare their options around both modernisation and migration. As an example, a colleague of mine recently worked with a large Australian retailer who was looking to move an SAP application to the cloud. The application was running on an older version of SQL Server, and the customer did not have the required licenses to move to a more modern version as part of the migration. We helped the customer model out the cost of migrating the application to AWS, and the largest cost number by far was SQL Server licensing. The application consumed 60 cores of SQL Server Enterprise, which cost hundreds of thousands of dollars a year, even when highly optimized. So, working with a local partner and the account solution architect, the team looked at whether they could help them modernize the application by moving that application to a different database engine. The partner rapidly identified the opportunity to move away from SQL Server to Aurora Postgres, which is the Amazon Web Services managed implementation of PostgreSQL. This strategy was successfully implemented, and the learnings were that the database transition and migration themselves were actually pretty easy. The only complications we experienced were in some of the periphery features of SQL, namely SQL Server Integration Services, SSIS, and SQL Server Analysis Services, SSAS. And the partner dealt with these by building custom integrations. The result was an extremely successful migration, and the retailer has since traded through both Black Friday and the Christmas period, which are the peak demand times, without any issues at all. Aurora Postgres comes in at 1/10 of the cost of SQL Server, and as the Aurora is a managed database service, the customer no longer needs to allocate resources to managing the database for this application as well. Now, a key point to call out here is that this was a single application that was being investigated for modernisation. It was just a single application. And the partner and the AWS solution architect were able to dive very deeply into the potential modernisation options. By contrast, in another example, the team worked on an engagement last year with a very large Australian natural resources company. This company was undertaking an RFP to select potential future cloud platform partners, and the scope of the RFP covered both migration and modernisation. The customer wanted to be able to do an apples-to-apples costed comparison of the benefits of modernising applications versus migrating them. To be able to deliver this comparison, the customer needed to understand which of their applications was suitable for modernisation, the time and effort involved in modernising each application, and then the expected payback in terms of lowered costs for each application. Significantly, this customer needed to undertake this analysis across a portfolio of thousands of applications. This scenario has long been a challenge. Historically, it's not been possible to cost-effectively assess a large portfolio of applications. Over the last few years, we've seen a number of approaches attempting to solve this problem, ranging from a cursory manual inspection of each application through to the creation of a Monte Carlo simulation to model up a range of probability outcomes across a portfolio. Now, needless to say, neither of these approaches were particularly successful. And in the case of the customer RFP I just mentioned, they ended up comparing their cloud options on a migration basis and excluding the modernisation as a potential strategy. For a long time, my view has been that we need some form of a tool or tool-like capability that we can use to assess and analyse a portfolio of applications at scale for modernisation. This is something that Amazon has been working on for quite some time, and today I'm pleased to be able to share with you the capability that we've built, which is called AWS Migration Hub Strategy Recommendations. For a long time now, AWS has provided best-in-class tools and services to help customers migrate workloads to the cloud. This includes AWS Migration Hub, which is a single place from which to plan, manage and execute all aspects of a migration project. More recently, AWS has also created a number of tools and services to help customers undertake modernization. For example, AWS Porting Assistance for .NET that helps customers move classic .NET applications to .NET on Linux. AWS App-to-Container Service that helps customers containerize legacy ASP applications without making any code changes. And more recently, Babelfish for Aurora PostgreSQL that allows applications built for Microsoft SQL Server to talk to PostgreSQL without any code changes being required within the application. At the end of last year, we brought all of these modernization tools and services into AWS Migration Hub with the creation of AWS Migration Hub Strategy Recommendations. This allows customers to analyze entire portfolios of applications for their suitability for migration or modernization. An automated process takes care of analyzing each running application, its process dependencies, and its technical complexity. Customers are then provided with prescriptive guidance that details the optimal strategy and the tools to migrate or modernize each application, along with an idea of the effort involved. This is a tremendous new capability, providing customers with a rapid and cost-effective mechanism to assess large portfolios at scale for modernization and the effort. Strategy recommendations can be used to analyze applications that are on-premise or that have already been migrated to AWS. The service itself is free. You only pay for the cost of the tools you use and any resources being consumed on AWS. Now, I don't have enough time in this session to deep dive into how the service works. There is copious information and documentation available on our website, and I'll provide my contact details at the end of the session, should you wish to chat with me and the team directly. So in summary today, we've covered how we can help customers optimize compute and licensing costs via an OLA for workloads that are migrated to AWS's virtual machines, that classic lift and shift. In addition, I've then covered the options open to customers who wish to modernize away from Microsoft operating systems and databases, finally put an end to expensive software licensing renewals and support costs. I hope you found this session successful. Please scan one or both of the QR codes on the screen to get started with your cloud skills, training and certification. Thank you for attending. We would very much appreciate your feedback, so please complete the session survey. Thank you and goodbye.